This video will show a universal joint assembly and animation using FreeCAD A2Plus workbench. Let me start now. Create a new file. Switch to A2Plus workbench. Add the parts yoke. The angle X, Y, and Z are all 0. It is the position of the yoke, and it is at fixed position. At the parts support, it is the base. Select the part, right-click the mouse, and select Transform. Rotation increment is set at 90 degrees. Rotate the base by 90 degrees. Select the circular edge of the yoke. Hold the Ctrl key and select the circular edge at the base. Then add circular edge constraint. Add the part coarse. Select the coarse, right-click the mouse and transform. Rotate it by 90 degrees. Select the circular edge of the coarse. Hold the Ctrl key and select the circular edge of the yoke. Also add the circular edge constraint. Select the yoke and duplicate the parts. Select the part, right-click the mouse to transform. Swing it to the other side and rotate it by 90 degrees. Select the circular edge of the yoke. Hold the Ctrl key and select the circular edge of the base. Apply axis constraint this time. Select the circular edge of the yoke. Hold the Ctrl key and select the circular edge of the coarse. Apply axis constraint too. Move the part under constraints. Select the yoke, but it cannot be moved because it is fixed. To solve the problem, select support and change fixed position to true. Then select the yoke and change fixed position to false. Now the offset angle between the input shaft and the output shaft is 20 degrees. Select Move under constraint icon, and then select the yoke and use the mouse to rotate it. In the next section, we'll create a simple macro to rotate the universal joint. Save and close the file. We open the file to update the file name in the system. Select View and open the Python console. Open the macro window and create a new macro. Select the yoke, go to Edit and send to Python console. Copy these two lines and paste in the macro. The first line is to get the document, and the second line is to get the object yoke. If the comment in the document is stuck, it will run the commands below. This is the command column in the document. The rotation axis is Y, which is represented by 0, 1, 0 in the vector. Y-axis in the pavement. This command is to increase the angle by 0.1 radian each time. We can put radian here as a remark. 0.1 radian is about 5 degrees. Change the angle to 80 degrees. This command only increases the angle but won't resolve the constraint, so other parts are out of place. Click the Solve Constraint button, and we can find the corresponding Python code in the console. Copy and paste it in the macro. The last command is to update all the windows. Save the macro. Now enter Start in the command. We can also use a command in the Python console to enter the command. Run the macro UJM. The universal joint is rotating now. You can see the position of the yoke is not exactly 0, but it is really close. The angle is keep increasing and pass 360 and start from 0 again. Use the Python console to change the command and install the macro. It changed to STA as in the console. Enter Start and we can run the macro again. If you found this video interesting, please subscribe and give it a like. If you want to see the details and construction of the yoke and the course, please follow the link at the end screen to watch the video Universal Joint by Assembly 4. Thank you for watching.